Hey, thanks for checking in, and welcome to the first lesson of Unit 5, which is called Linear Systems. So your learning target today is that you are going to graph a system of linear equations. The good news is that you've already been graphing linear equations, and now we're just going to take this one step further to something that's called a system of linear equations, which is, according to this definition here in green, a system of linear equations is just two or more equations that have the same variables. So we're going to be talking about graphing two or more linear equations that have the same variables. And the variables that we'll be looking at, of course, will be x and y, as they have been for many weeks now. Essentially, let me tell you in my own words what you're going to be doing today. You are going to be graphing two linear equations like this. Remember this guy, y equals mx plus b, where this is your slope and this is your y-intercept. You're going to be graphing two of these guys on the same coordinate plane. And then once you get them both graphed, you're going to look to see what happens between those two lines. There are three things that can happen when you graph a system of linear equations. And again, it's called a system because there are two or more equations graphed together at the same time on the same coordinate plane. Now, the three things that can happen when we graph these two lines, this system, and we check to see what happens between them. One thing you might notice when you graph them is that there is one solution for the system. That means when you graph your two lines, you will notice that they cross each other at one point. So for example, I might graph this line here in blue and it might look something like that. And then I graph another line here in green and it looks something like that. And if you notice, these two lines cross each other at one point. Whatever this point would be on the coordinate plane, that would be the solution. That would be the one point, the x and y value, that solves both linear equations. Okay? Or maybe when you graph your lines, maybe you notice that they are parallel to each other. They never crisscross one another, and that's called no solution. So maybe I graph and I get this blue line like so. And I graph my other equation on the same graph, and I notice, holy cow, these are parallel lines. That means never ever do they cross one another, and there is not an ordered pair for the blue line that will also work for the green line. There is no x and y value that they share in common. And yet the third option down here is called infinite solutions. That means that the lines end up being overlapping, meaning they end up being like the exact same line. So here we go again. I'm going to graph my blue line. Okay, I get this when I graph my line. Of course, I'm just kind of estimating or kind of making that up. And now I go to graph my green equation or my green line, and I notice, holy cow, they completely and totally overlap one another. And when the lines are overlapping, or they end up being the exact same line, that's called infinite solutions because every point on the green is also a point on the blue line. It just keeps going. So there are an infinite number of x and y pairs or ordered pairs or coordinates that would work for the green as well as the blue. So again, let me say, what you're going to be doing today is you're going to be graphing two equations on the same coordinate plane. And then you're going to be looking to see, do they cross at one point, which would be one solution? Are they parallel lines, which would be no solutions? Or do they end up being the exact same line, which would be an infinite number of solutions? That's what you're going to be doing. So hopefully you're pretty confident at graphing. So here's an example. Here's one I did for you. It says solve the system of equations by graphing. All right, so we've got two equations here. We've got y equals x, that's going to be the red line, and then I've got y equals negative 3x plus 4 as the blue line. Well, let me Let me fix up this red equation over here, this y equals x. Just to make sure we understand from our previous unit, y equals mx plus b, I need to fill in some missing values over here in order to make this probably look a little bit more familiar to you. What if I were to tell you that y equals 1 over 1x plus 0? Does that look a little bit better for graphing? I bet it does. And over then on the blue one, the only thing I'm going to really fix up on the blue one, where it says y equals negative 3x plus 4, I like that to be over 1. I just think that helps with graphing and with finding slope and whatnot. So, there we are. Here I am, I'm going to graph this red line, although it's actually already been graphed for me. Y equals 1 over 1x plus 0. So this plus 0 right there, that's your y-intercept. And from there, you use the slope of up 1 over 1, and I put these points and I graph the red line. Up 1 over 1, up 1 over 1. Awesome. Now I'm going to graph the blue line. So I look at the blue equation. I look at the y-intercept of positive 4. So I put a dot there at positive 4. And I look at my slope, which was negative 3 over 1. So I went down 3 over 1. Down 3 over 1. And I graphed my blue line. And lo and behold, do you see that these lines do in fact cross each other at that one point that I circled in black? This point right here is where they cross. That is the one point on the red line that also works for the blue line. So that is called the solution of the system. Now, if they ask you to name that point where they cross, that is over 1, up 1. So that's where the x is 1 and where the y is 1. So that is the point 1, 1. That is the solution for that equation. It has one solution because it crosses at one point. All right? Now, we've got some more examples, 3 more examples. All right? Here we go. Let's graph these things. Let me get myself some more room here. There we go. Awesome. So here's my first equation. I'm going to graph this guy in red. He'll be my red guy. And you know there's a 1 over 1 there for the slope. So I'm going to start off with my y-intercept, which is positive 2, and I'm going to put a red dot on positive 2. And then from there I use my slope. I go up 1 over 1. And you know what? I'm going to keep going in this pattern, down and left, down and left, down. I don't really know how long I need to make this line, so I'm going to make it pretty long. All right, here we go. See how straight I can draw. Well, not terrible. There we go. I graphed my first equation. Now I'm going to graph this guy in blue, and let's not forget that's a negative 2 over 1. So I start with my y-intercept. Y-intercept is negative 4. I go down 4, 1, 2, 3, 4. There it is. And the slope is down 2 over 1, down 2 over 1. Well, that doesn't give me much room, so I better send it the other way. Up to left 1, up to left 1, up to left 1, up to left 1, up to left 1. All right, I'm going to draw this blue line. Down she goes. And do they cross? Yes, they do. They have one solution. And that solution is negative 2, 0. Very good. Let's do this one. All right, again, this will be my red line. And really that's a negative 1 over 1. Here's my y-intercept. Down 1 over 1. Right, I'm just using that slope as my driving directions. And remember, I have to make a long line because I need to see if they cross or if they don't cross or what ends up happening. Same thing over here. Y equals negative x, which means negative 1 over 1 x minus 3. Y-intercept of negative 3, 1, 2, 3, there it is. Down 1 over 1, down 1 over 1. Or up and left, up and left, up and left. Oh my goodness, what kind of lines do I have here? Those are parallel lines. Guess what? They are never going to cross each other. there is no solution. Oops, if I could spell. How about this? That's better. Never do these lines cross each other. There is no solution for this system of equations. I think we should do one more. There it is. Whoa, man. I see an equation that's going to need some work. Let's do this guy first. Y-intercept of -1, disco right there. My slope is up 1, right 2, up 1, right 2, up 1, right 2, or down and left, down and left, down and left. Fantastic. There's my red line. I love it. Now, this guy that I'm going to do in blue, we have to do some work to him. He's not in good form. So I'm going to send the x over to the other side. So I'm going to have a -2y equals a -x plus 2. Divide by -2 all the way across. Y equals -1 over -2x minus 1 when I divide by -2. So now y equals 1/2 x minus 1. All right, let's graph this guy in blue. Y-intercept of -1. And my slope is up 1 over 2, up 1, up. What's happening? These end up being the exact same line. Because the equations are the same when you get them into good form. These end up being the exact same line. We say this is an infinite number of solutions. Remember, this little symbol that I just drew, like the sideways 8, means infinite. Infinite number of solutions. Because they're overlapping lines and they end up being the same line. Of course, we're going to be working on this in class over the next few days. All right? I will see you then.